Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a very interesting homemade system of equations with complex numbers. How complex this can get, right? So we have the following system. W and Z are complex numbers, needless to say, I guess. W plus ln z is equal to I, and Z plus ln W is equal to 1 plus pi over 2. It's actually supposed to be 1 plus I times pi over 2 as far as I remember. Anyways, so I forgot the I there. Let's go ahead and add that real quick. Hopefully, I'll fix it on the thumbnail if I made the wrong one. Great, now let's go ahead and see how we can solve a system like this one. So I'm going to present a method since this is kind of like a transcendental equation. I don't think we have a really standard way of solving it, but I'm going to try my best. Okay? So, and if you think about how I came up with this problem, because I called it homemade, didn't I? And then you'll understand the logic behind it. So let's go ahead and do the following. Since we have the logs, the logarithms, the complex logarithms, and the numbers themselves, I think it'll be easier if we use the polar form. So, by the way, if you're new to complex numbers, go ahead and check out my lecture videos and ask a lot of questions. I have another channel if you like number theory, algebra, and trigonometry, tiny bit of geometry here and there. I'm still thinking about a geometry problem that I want to do, hopefully anytime soon. And my channel is called Cybermath. That's actually my very first channel many years ago during COVID. Anyways, Cybermath, it's cyber with an S. I can't talk today, I don't know, for some reason. So there are two main forms of complex numbers. One of them is the standard form. So for example, you can write W as A plus BI, or you can also write it in the trigonometric form, which is much better in this case, and that would look like the following. Let's start with Z first. So Z, we can definitely write it as A plus BI, which is the name of this channel, by the way, in case you forget. But we can also write it as R times e to the power I theta. Of course, in this case, thanks to Euler, we have an identity. E to the I theta can also be written as cosine theta plus I sine theta, and it's actually the most beautiful equation in math, if you think about it. Now, why do we go with the polar form? Because it's compact, and actually working with exponents is a lot easier. Imagine you use Z equals A plus BI and W equals C plus DI. Then you would have to deal with something like this. C plus DI plus ln A plus BI equals blah, 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 right? This is complicated. Don't make things harder on yourself. So let's go ahead and use the polar form. Again, thanks to Euler, because he is the best. Great. So here's what we're going to do then. We're going to replace Z with R times e to the I theta. In this case, by the way, again, I go over these in lecture notes, lecture videos, I mean. R is the modulus or absolute value, and theta is called the argument, which is the angle. So basically a complex number can be represented like this as a point or a vector. Okay, great. So what about W? Let's go ahead and call that S times e to the power I alpha. Obviously, they don't have to have the same moduli and arguments, so we can make them different, okay? In this case, S represents the absolute value of W. Okay, great. Let's go ahead and plug these in now. We have our equation, W plus ln Z. And W would be S times e to the I alpha. And how do you ln an exponential like this? Actually, that's very easy. You just ln the R, and then you add the I theta. So that's really cool about ln Z. If Z is defined as such, then ln Z is just going to be ln R plus I theta. Now, of course, theta is considered the principal argument, so we take the smallest angle between negative pi and pi. Obviously, you can just rotate, wrap around the unit circle. Now, you gotta distinguish between these two ln's. That's why some people use log for this. A lot of times, books will use log because this is the complex logarithm. But I do use ln. So these two ln's are different. This is a real valued ln. This is actually a complex logarithm, okay? So, of course, that's going to be followed by I theta. And then the second equation, which is Z plus, did I write that right? I think so. W plus ln z was the first one, right? Yep. Z plus ln w is just going to be then r times e to the I theta plus I alpha. Okay? Cool. So we got this type of system, but we also know that the left-hand side is equal to the right-hand side. What am I talking about? So this is supposed to equal I, and this is supposed to equal 1 plus I pi over 2. Awesome. Now, it would be nice if you could just say, hey, this is the imaginary part and this is the real part, but that's not the case because this is just another complex number. So we kind of need to break things down. That's where the trigonometric form, which is a little longer, comes in handy. So we're going to go ahead and do the following. Forget about this part now. We don't really need that anymore. But let's go ahead and rewrite this with the trigonometric versions. So this one is going to be r. I'm going to start with that because it has the z in it. Doesn't matter. You can do the other way around too. But r times cosine theta plus I sine theta. That replaces e to the I theta, as I said before. Plus I alpha is equal to I. You can go ahead and simplify this or do both at the same time. Let's go ahead and simplify this. R cosine theta plus r I sine theta plus I alpha is equal to I. Now, in order to be able to compare two complex numbers, you need to separate the real and imaginary parts. So let's go ahead and put these two together because they make up the imaginary part. So we're going to write the I first, r sine theta plus alpha. Great. And this is equal to I. Now I can compare them easily. If you do the same thing with the other equation, which is, by the way, let me write it down here. It is actually the first one, w plus ln z. So it's going to be s times cosine alpha plus I sine alpha. I want to write the first version here because when I simplify, I want it to be down here along with the other equation. And now I'm going to go ahead and distribute and simplify. And can I skip a step here if you allow me? S cosine alpha. And then notice that this is going to give you an imaginary part. This is going to give you another imaginary part. So if you factor out I, I'm hoping you can do that. S sine alpha, be careful with that, plus theta. That's going to make up the imaginary part. And remember, this is equal to 1 plus I pi over 2. Great. So now we have our system, and that's what we're supposed to solve. But wait a minute. There are 4 variables. Yes, and 2 equations. That's not a problem because we're dealing with complex numbers. They're 2-dimensional. So this actually gives us 4 equations. How? Comparing the real parts. If you look at equation number 1, let's call this number 1 and this number 2. You notice that the real part on the left-hand side is r cosine theta. On the right-hand side, there's no real part, so it's 0. Beautiful. Isn't that awesome? And then I'm thinking that we might have forgotten to do something. Oh, yeah. Okay, I think I forgot something. R times this plus, oh, okay, ln w contains more than that. Okay, so we're going to back up a little bit and fix this. Let me go ahead and fix it. I just realized I'm missing some terms here because it wouldn't be this easy. R cosine theta equals 0? No way. Okay, wishful thinking, right? Okay, let's go ahead and fix this now. So let's start with the first one. I think that's what is kind of confusing. So for w, we have s e to the I alpha plus ln z is actually going to be ln r plus I theta. This is the part that I forgot, okay? And this is equal to I. And then for the first one, r e to the I theta plus ln s. This was the missing term. And this is equal to 1 plus I pi over 2. Did I get that right? Hopefully. Okay. Now, I think so. Now, we're going to go ahead and expand it. Like I said earlier, these are going to be turned into trigonometric forms. And I don't have to do it again. Let me just give you the result. This is going to give you, the first one is going to give you s cosine alpha plus ln r plus I times s sine alpha. Remember, we've done this before. Plus theta. This is equal to I. Okay? And the second equation is going to give us r cosine theta plus ln s, plus I times r sine theta. So variables kind of switch. You get the idea, right? This is equal to 1 plus I pi over 2. Hopefully you can recognize this number. Great. Now, we got ourselves a system, so we're going to solve this. And to be able to solve it, actually, this is incorrect. So let's go ahead and, actually, that's not incorrect. Never mind. I'm confusing myself many times. Now, we're going to go ahead and compare the real parts. So this part is 0. As you can see, S cosine alpha plus ln r is 0 because there is no real part on the right-hand side. And this is supposed to be 1. So S sine alpha plus theta is equal to 1. Great. So we've taken care of the first equation. And now we're going to go ahead and use the second equation and write another system. Notice that each of these equations, because they're complex numbers, turn into a system. So we end up getting 4 equations. That's the cool part, right? Great. And then from this one, we're going to get r cosine theta plus ln s. Notice that on the right-hand side, we have 1, so it's equal to 1. And from here, we get pi over 2 because that's the imaginary part. So r sine theta plus alpha equals pi over 2. As you can see here, clearly, right? We have 4 equations and 4 unknowns, rs, theta, alpha. Can we solve it? I mean, hypothetically, yes, but analytically, no, because this is a non-standard equation, or some people call these maybe a transcendental system. Unfortunately, there's no analytical method, as far as I know, but I will make it easier for you to solve it. We're going to make some assumptions. Obviously, you can talk about a family of solutions. Let's just say that, okay, suppose this is happening, so on and so forth. Okay, we'll get into that in a little bit. Let me go ahead and show you what I'm talking about. So from here, you can do one thing that'll be kind of helpful, and that is using the trigonometric identities, okay? And how does that work? For example, here, we do see that both of these have r cosine theta and r sine theta. They are actually related. And if you think about the polar coordinates, obviously, they are, right? Or polar graphs. So here's what I'm going to do. I'm going to isolate r cosine theta from equation. So let's number these equations again. Oops, I'm not good with arithmetic, am I? So 1, 2, 3, 4. And then I'm using equation 3 and 4 now. And isolating r cosine theta, I get that. And isolating r sine theta, I get this. Okay, awesome. Now we're going to do the following, which is fun. We're going to go ahead and square both sides. And when you do square both sides, and the reason behind it, because when you square, you're going to get cosine squared and sine squared. When you add them, you're going to get 1. Make sense? So r squared cosine squared theta is just going to be this number squared. And r squared sine squared theta is just going to be this quantity squared. You could also write squares on both sides, no big deal, if this notation bothers you, okay? I know some people act like rigor police. No, you can't write it like that. Too bad, I did. But anyways, now, we're going to go ahead and add these up. That gives us r squared times sine squared plus cosine squared, which is factoring, equals 1 minus ln s quantity squared, pi over 2 minus alpha quantity squared. And as you know, this is equal to 1. So this gives you r squared. So without further ado, let me go ahead and copy this and bring it over here. Oh, I didn't mean to bring the line down, but anyways, we can get rid of that. Now, this equals r squared. Is that good? Well, I don't know. Maybe. Here's the problem. We still have a lot of unknowns. But one thing that you can do that will definitely make your life easier is making some assumptions. First of all, the easiest route, in my opinion, would be to assume that r equals s equals 1. What is that supposed to mean? It just means that the moduli of these numbers, because there can be infinitely many solutions in this case, and by assuming r equals s equals 1, we're just looking at a particular solution, which is fine, right? Sometimes differential equations are not solvable, but you can find numerical solutions or some particular solutions. Now, if you plug these in, ln 1 is going to be 0, so that gives us 1 plus, right? Alpha pi over 2 minus alpha squared equals r squared, which is 1. So this becomes 0, which means from here alpha becomes pi over 2, which is beautiful, right? Now, if you assume this happens, then this happens, which is really cool because it simplifies our system a great deal. But not only that, it also simplifies the other equations because if you really think about it, R and S are both equal to 1. So from here, for example, and remember, we found alpha, so our goal is now to find theta. So let's go ahead and just take a look at this. Alpha is pi over 2. Subtract it, you'll get 0. Since R can't be 0, sine theta needs to be 0. If sine theta is 0, then theta has to be what? A multiple of 2 pi, where n is an integer, right? So we got the values of alpha and theta. What is that supposed to mean? It means now we're going to try to find everything else, right? Well, we do know everything else because R equals 1, S equals 1. So we're going to go ahead and actually pair these together like this and like that. So now remember, our assumption was Z equals R e to the I theta, right? Z equals R e to the I theta. So it's going to be just e to the power I times 2 pi n. And W was S e to the I alpha. S is 1, so it's going to be e to the power I times alpha, but alpha is pi over 2. And remember, I asked you, like, you probably, hopefully you're familiar with I pi over 2. E to the I pi over 2 is equal to I. This is equal to 1. It's actually very important because that's how you write 1 in the complex world. So 1 and I satisfy this equation. But is that the only solution to the system? That's for you to find out. And also, do you think Wolfram Alpha can give us an answer for this one? Let's go ahead and check it out because I did, and I want to share the results with you. But do you think an LLM, whatever you want to call it, I call it an LLM now, not AI, an LLM like Wolfram Alpha, do you think Wolfram Alpha can figure this problem out, at least find particular solutions? What are your guesses? Ta-da-da-da. Too bad. It cannot find because it's looking for real solutions. I probably said complex solutions for this. I can't remember the prompt, but it should be like that. But anyways, something to laugh at, right? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out the Shorts channel, Cyber Math, and aplusbi. And until next time, bye-bye.